Okay, so we'll go through the topic 3A. So this experiment is to determine the empirical formula of copper 2 oxide. So the idea is this. We will have these two chemicals, zinc and hydrochloric acid. They will produce the hydrogen gas. So this hydrogen gas will pass through this anhydrous calcium chloride. So anhydrous calcium chloride, the purpose is to dry the hydrogen gas. You absorb all the water vapor in the hydrogen gas. Then sometimes if you don't want a solid like anhydrous calcium chloride, you can replace it with some liquid like a concentrated sulfuric acid. It also can absorb the water vapor. Once you pass through this drying agent, you'll get dry hydrogen gas. Then in here, we will have copper 2 oxide. So at the beginning, we have copper 2 oxide, so we'll have the mass of copper 2 oxide. Then after the reaction, because hydrogen is more reactive than copper, you'll take away the oxygen, so you're left Cu here. Then you're able to get the copper mass. Then the difference, from difference, you were able to calculate out how much oxygen is removed. Then you take the mass of copper, minus of the combustion unit, you're able to get the mass of copper. Then after that, you take the number of mole equals to mass over mass, you get the number of mole of the copper and oxygen. From there, you will see the ratio is 1:1. So the empirical formula will be 1:1. Then there's some precautionary steps, like you need to make sure the hydrogen gas is allowed to flow through a few minutes before you heat copper 2 oxide to remove all the air in the tube. Why I need to do this? Because if he has oxygen and hydrogen inside, you light up, you will be explode. Okay, the idea is this. Originally, you have your air has oxygen inside. So if your hydrogen move in and you heat, right, explosion will occur. So what you need to do is you keep flowing a lot of hydrogen gas inside, because as you flow more and more hydrogen gas inside, you're actually forcing the air inside to go out. Example, let's say, we have a lot of hydrogen gas come in. Okay, all this hydrogen gas come in, you'll force the oxygen to go out. So at the end, right, this combustion tube only has hydrogen, and then you heat, it won't explode, because explosion and combustion need oxygen. Okay, so then after that, to ensure the reaction has complete react, we will repeat these three processes. Heat already, cool down, measure the mass. You repeat few times to make sure all the copper 2 oxide has changed to copper. How do you confirm this? When the mass is fixed, that means it's already all changed to copper 2 oxide. So this is another experiment, similar one, that throughout the experiment, you also need to make sure the hydrogen gas must continue flowing, is to make sure the air don't move in, because if moving, explosion also might occur. Second one, if oxygen come in, right, they will react with the hot copper metal to form back a copper 2 oxide. So this is what we do. Okay, this is another experiment which is very similar, but you see here, this is hydrochloric acid, this is zinc. So these two react will come out hydrogen gas. Then this hydrogen gas will pass through here, then you'll react with the copper 2 oxide. It's exactly actually same experiment, it's just more simplified version. So when come up with this question, we always ask you about empirical formula. So what is empirical formula? A chemical formula that shows the simplest whole number ratio of atom of each element in the compound. So how do you dry the hydrogen gas? Is flow the gas through the anhydrous calcium chloride or concentrated sulfuric acid, also potential. What's the purpose of the zinc granule and hydrochloric acid? Is to produce hydrogen gas. This is the chemical equation. Zinc plus hydrochloric acid will become zinc chloride and hydrogen gas. What change can you observe? Now, copper 2 oxide is black color. Copper is brown color. You will see black color turn brown because black is copper 2 oxide. Okay, then after that, you will turn brown, become copper. So how do you find the mass of the what we call the to get the copper mass, you have to take this one minus the first one. To get the oxygen mass, you have to take the third one minus the second one to get the oxygen mass. Then you divide by the molar mass. One is 64, one is 16. Then you're able to get 0.2. So the mole ratio will be 1:1. So the empirical formula will be CuO. Write the chemical equations for the reaction between oxide of copper, so CuO, we found the empirical formula is CuO plus hydrogen gas. Then you become copper, then hydrogen is more reactive, you take away the oxygen, become copper 2 oxide. Why does hydrogen need to flow through continuously throughout the experiment? So to make sure all the air is removed, if not explosion occur if you heat the mixture of oxygen and hydrogen. Can empirical formula of magnesium oxide determine using this method? Now, if you look at the reactivity series, you realize that hydrogen it can take away oxygen from the copper because it's more reactive, but it cannot take away oxygen from the magnesium. So any metal that below here can use hydrogen to determine the empirical formula, but anything above, right, you weren't able to react with hydrogen gas. So those that anything above, you use the second experiment, which is called combustion tube, which is this one we'll discuss in topic number 3b. Okay, so the answer is no. Why? Because magnesium is more reactive than the hydrogen, so hydrogen cannot take away oxygen from the magnesium. So hydrogen gas is allowed to flow through until the product is formed. Why? Is to make sure the air don't enter back, because enter back, it will react with the hot copper to go back to your copper 2 oxide. So you have to wait until your copper become cold. Then only you can stop the hydrogen flow. Okay, why do the heating, cooling, weighing process need to be repeated until constant mass is obtained? So to ensure all the copper 2 oxide is completely changed to copper. Okay, this is the next experiment. So this experiment is similar. You can try by yourself. The only difference here is instead of using copper 2 oxide, you change to PbO. Just this is the only difference. The rest is the same. Okay, so you can try to find the mass of lead. Take the third one minus the first one. Then how to find the mass of oxygen? Take the second one minus the third one. Then get the ratio, number of mole for both sides. You get same, so the ratio will be 1 to 1. So the empirical formula will be PbO. Then from there, you can start to write out PbO, write hydrogen. Then they'll take away the oxygen from Pb, you get your H2O. P is located above hydrogen. Now, if above hydrogen, we weren't able to use this experiment, so we have to change it to the crucible experiment. So this is the diagram they are required to draw. So for this experiment, you have to open up the lid is this, the cover here, because to allow oxygen to enter and then to react with the metal P. Then try question 3. This question 3 sees slightly change a bit. Instead of they don't give you copper 2 oxide, don't give you PbO, but they give you metal Y oxide. So it's very similar. What is the two chemical required? You see, the same question, if you did the first time, maybe you copy the answer, but the second time you start to see the similarities. Until this third question, although they change a bit, but you don't feel anything because you did this question before. Example, who will produce hydrogen gas? Zinc and hydrochloric acid. So the chemical equation, what is the function of anhydrous calcium chloride to dry the gas? Why must hydrogen gas pass through a period of time to make sure all the air, all the oxygen is out of the combustion tube? If not, hydrogen and oxygen mix with heat explosion occur. After reduction, a steam of hydrogen gas is allowed to flow through a while. Why? To make sure there's no air enter inside, to avoid the hot metal back to metal oxide again. During the heating cooling process is repeated until constant mass to make sure all the reaction finish. My reaction is metal Y oxide change to metal Y, take away all the oxygen. Then you try to calculate out. This is Y oxide, this is Y. So Y is 4.14. Y oxide means you have to minus off the Y. So it's 4.78 minus 4.14. Then find the number of mole for both sides. So you can see the ratio is 1 to 2. So the empirical formula will be the Y and then 2O, YO2. So write a balance equation. So I got YO2, write a hydrogen gas. It will take away the oxygen, become H2O. Then we balance the equation, 2 here, 2 here. Okay, then we go to the last question. Same thing, it changes to M oxide. So 2 chemical to prepare hydrogen gas. You can see until the fourth question, you start to very confident. And this kind of question came out, you can see the differences. School question might be a bit different, but it won't be a challenge for you. So it becomes the zinc plus hydrochloric acid becomes zinc chloride and hydrogen gas. So how to dry it? You can use the anhydrous calcium chloride Precaution taken, you must flow through a few minutes to remove all the air before it hit, if not explosion will occur. How to ensure all change to, all reduce means all metal oxide become metal, is to repeat the three process. Heating, cooling, weighing process is repeated until a constant mass is obtained. Then you try to find the mass of magnesium. To get the mass of the M will be the with N and minus without N. Then the oxygen is with the O and without O. Then you divide by the molar mass. One is 48, one is 16. You get the ratio is about 1 to 2. So we can say the empirical formula is MO2 lah. Then MO2, rare hydrogen gas, it become M plus H2O. And put 2 here, put 2 here. Can empirical formula magnesium also using this method? The answer is no, because magnesium is more reactive than hydrogen.